Hello, this video is to share our project on United Nations Goal 4, which focuses on ensuring inclusive and equitable quality education for all. In this project, we've each explored a different aspect of education through data analysis to better understand the challenges and opportunities in achieving this goal. Together, we hope our findings shed some light on the complex issues facing global education and inspire further efforts to achieve inclusive and equitable learning opportunities for everyone. We've split our research into 3 questions to tackle some of the important areas surrounding education. First, I'll be talking about education inequality, exploring how disparities in education access and quality differ within and between countries of different economic status. My name is Jaden, and my focus within our project is on understanding how economic factors affect education inequality. To explore this issue, I started by gathering data on education duration, attendance rates, and school life expectancy. These datasets showed disparities both within and between countries. My research question was on how education inequality varies across countries with different levels of GDP. This question is important because addressing education inequality is important for promoting inclusive and equitable education, which is in line with the United Nations Goal 4. For my analysis, I used data from 2 primary sources: the UNESCO Institute for Statistics and the World Bank. The UNESCO data provided insights into education duration, attendance rates, and school life expectancy, while the World Bank data offered information on GDP levels for countries. Using these sources, I grouped countries by their GDP into low, low middle, middle, upper middle, and higher. I did this to compare group to group and not country to country. Next, I conducted analysis using the skills we've learned over the semester. I calculated the percentage of students absent from education for each country from the years 2017 to 2023, based on education enrollment data and out-of-school population data. This approach allowed me to understand how many years of education were lost on average due to absent students. To visualize the findings, I created a few graphs. For example, in higher GDP countries, the distribution of required education is generally around 9 to 10 years, while in low GDP countries, it's typically shorter. The average education years lost due to absent students were consistently higher in lower GDP countries, highlighting the inequality in education. In conclusion, my analysis showed that the average education years lost is closely tied to a country's economic status. Lower GDP countries experience more loss in education access, leading to more years of education lost. These findings show the importance of research to address education inequality and ensure that all children have access to equal education, regardless of their country's economic status. My research helps us better understand the factors influencing education inequality. Thank you.
Hello, my name is Tom, and welcome to my part of project. And my part of project is observing how government GDP spend percentage on education will affect enrollment. So the first thing that we did is load in all the data with the PD. Next, we filtered it to what we want, which is an indicator, country, time, and value. Next, here we sorted all of them to what we need. For example, the government GDP here, we have the tertiary, which is university, and secondary, which is high school, and primary, which is kindergarten to elementary school. And here, pretty much just sorted all of them, so we have the data that we could use. And we also printed out the mean of the school life expectancy, the standard deviation, and the average of how much government will spend on education, and the standard deviation of it. Next, here, we pretty much group the data by their country and their mean, which is their average, to see how many people are actually enrolling on the average in a country and the average of how much the government will spend. And we have three total category of it, which is primary, secondary, and tertiary. Then we merge the data set so we could actually use it, because if we don't merge it, the size will not be the same, and then we can't graph it. So this part ensures that we could graph it. Next, we created a line of best fit by using the polynomial function, which is nice because these lines are linear. So by using polynomials, we can actually get the best line of fit on this. Then this part, we pretty much plotted all three to graph, and I plot all three at the same time by using the subplot function. And from here, we could see the layout of it. And as we can see, secondary and primary is relatively kind of the same. I mean, the primary is definitely a little bit more, I guess. But if you look at the slope is pretty much the same. You're not going to really see a difference. But on the other hand, if we look at how much the government spends on tertiary, which is university, we can just see that line of the slope is exponentially just higher than the other two, which leads us to think, so if the government spends more money, does the enrollment increase then? So next, by just confirming it, I clustered the data. So pretty much same thing, kind of cleaned it up, merged them, and then did some clustering, and pretty much we had to get rid of a lot of null and infinity values so it could work. And from here, it pretty much confirmed our findings, which is that the government has much, much higher spending on university compared to primary and secondary education, which makes sense because their main goal is to create more higher literacy country, but by having higher literacy, it means also higher productivity, which is increases GDP on the long run. Pretty much, it's kind of similar to them investing in themselves, which shows that this does really work. So if they do spend more money on which part of the education, the enrollment will increase significantly, and which is proven by university here.
We focus on how global economy aligns with UN number 4 goal, quality education. And now, we're going to focus more on the United States. In this section, we are going to discuss how bullying affects quality education. Now let's take a look at the code. The first coding block is where I import all the necessary libraries. The first data is a worldwide bullying data, and since I'm going to focus on United States, I select the role for United States to explore and dig deeper. Next, I have a data from Google Trend which shows searching interest on topic over time, as we can see in the graph. The peak happens to be around 2010 to 2012, and the topic bullying has a higher interest than cyberbullying. Next, I found a data that shows cyberbullying victim rate among middle school and high school during 2007 to 2019. Even though there's an up and down in the data, overall, it still shows an upward trend. Luckily, I found a full bully cases from 2018 report data. And since there's a lot of information that is unnecessary, I cleaned up the data, make it into a new data frame that contains in school, out of school, cyberbullying, age, and gender. From the first graph, I group all the cases by age to determine in what age group did most of the bully cases take place, which end up the age group from 13 to 17 is where most of the bully cases take place. Next, I do the same thing for gender and bully type, which end up cyberbullying and female has become the most common cases that's been reported during 2018. And overall, from this graph, we can also see that female has a higher reported cases for for being bullied. Next, I have a data that shows students that drop out for different reasons from 2011 to 2021. Same, I cleaned out the data and then have a data frame that contains the total number of students that's been drop out because of cyberbullying or bullying, female, male, and which year. From the first graph, we can see that over time, cyberbullying has become a more common cases for students to drop out. Next, I do the same thing for gender. Even though 2021, there's more male who drop out because of being bullied. But overall, we can still see that female has a higher rate of dropping out of school because of being bullied, experienced through bullying. And this is a total student dropout by years, which shows that there's a trend up and down. Especially 2021, there's a humongous amount of students who drop out because of being bullied. Lastly, I have a cyberbullying tweet, which I run through natural language processing, and then determine what language will be considered as bullying, whether a language will be considered bullying, and even when the tweet is considered a cyberbullying tweet, what's the most common words that's been contained in the tweet. From the graph below, we can see that if a cyberbullying type is gender related, the most common word is going to be gay, joke, rape, call, female, etc. From all the data that shows above, we can conclude that bullying definitely has a huge impact on quality education due to the fact that there's a lot of students who drop out of school, and then a lot of students been experienced through cyberbullying in school. Thank you.